In this video, we're going to be looking at some applications of solving by factoring. So we're going to look at a couple of word problems that we're going to be able to use that zero product property to solve. So in our first word problem, we have Patrick and Colin and they're playing catch on Mars. And Patrick throws the ball and we have this function here, h of t, that's going to represent the height of the ball above the ground at time t seconds since he's thrown it. Right, so just a quick reminder of that function notation, right? My function is h with my input t. It's represented by that polynomial I see on the right side. Our first question is, when is the ball 3 meters above the ground? So that function notation tells me that the left-hand side, that h of t, is telling me a number of meters, right? It is a height. So I'm going to replace that part with the 3. So I'm going to say that 3 is equal to negative 2t squared plus 3t plus 2. Now this looks exactly like those problems we've seen earlier in the section, right? I have some polynomial, I want to get it set equal to 0, I want to factor it, and that'll give me those t values. So I'll start with getting it set equal to 0, right? I need to subtract that 3 from both sides, and that'll give me that 0 equals negative 2t squared plus 3t minus 1. I'm going to skip some of those intermediary steps of doing the factoring, but eventually I'm going to get down to 0 is equal to 2t minus 1 times negative t plus 1. Okay. Now we're going to move on to doing that zero product property. So I've got that 2t minus 1 equals 0, and I've also got that negative t plus 1 equals 0. So solving this out for those t's, on the left side here, I'm going to get that t equals a half. On the right side there, I'll get that t equals 1. So the answer to this question is going to be that the ball is 3 meters above the ground, half of a second and 1 second after Patrick throws it. So you notice that there's actually 2 answers to this problem, right? Think about throwing a ball up in the air. It kind of goes up for a while and then comes back down. So it makes sense that it could come up, hit 3 feet, maybe go a little higher, and then come back down, hit 3 feet above the ground again. Okay. This question is also asking us if Colin doesn't catch the ball. So imagine Patrick throws it and it just sails right by his friend, hits the ground. How long does it take for the ball to hit the ground? So now, something to remember in these word problems, the ground is 0 feet, right? The ground is 0 feet above itself. So, in the last problem where I put that 3 on the left side of the equation, this time I'm actually just going to put a 0 on the left side of the equation. I want to know when the height is 0. So if 0 equals negative 2t squared plus 3t plus 2. Again, I'm going to skip some of those intermediary steps of factoring this equation. But if you go through those steps, you should get down to 0 equals 2t plus 1 times t plus 2 times negative t plus 2. Okay. Now I'm going to use that zero product property. I'm going to say 2t plus 1 equals 0, or negative t plus 2 equals 0. This time around, I'm going to get, on that left-hand side, t equals negative a half. Or on this right-hand side, I'm going to get t equals 2. Now this time, we're actually not going to use both of those answers. Let's think this through. So it's going to hit the ground at 2 seconds. That makes sense, right? He throws it, 2 seconds later, it hits the ground. But according to our model, it also hits the ground at negative half of a second. But that doesn't really make sense, right? It doesn't make sense to go back in time before Patrick threw the ball. So all we want to do is use this positive value here. It's going to happen a lot in word problems. The model really is only good for time moving forward, right? It doesn't make sense to put in any sort of negative time. So the answer to this is that the ball hits the ground 2 seconds after Patrick throws it. All right, let's go ahead and move on to our next word problem. So in this word problem, Allie wants to build a fence, and it's going to enclose 30 square feet. I want that 30 square feet to be a rectangular area. And Allie's decided that for good luck, she's going to have the length of this enclosure be 7 feet more than the width. We want to find the dimensions of that fenced area. So a quick reminder, for rectangles, the area is just equal to the length times the width. So, real quick, I'm just going to go ahead and let the width be x. I'm going to define variable x. It's going to be the width of the enclosure in feet. Okay. So I know that the area is 30 feet, so I can replace area with that. I know that the width is x, so I'm going to replace the width with an x. And I know the length is 7 feet more than the width. Remember, more than is an addition. So I'm going to do an x plus 7 in place of the width, in place of the length, where x is the width. All right, and now that I've got that equation written down, I know it doesn't quite look like it yet, but this is just like all those other problems we've done. We have some polynomial. We want to be able to solve for those values of x. So we're actually on this right-hand side going to have to multiply it out first, right? Because it's not equal to 0. If it were equal to 0, we could just go straight into that zero product property. But it's equal to 30. So what I would have is 0 equals x plus 7 times x, and then minus 30. And that's not a product, right? I have that difference in there that's stopping me from being able to use the zero product property. So in order to factor this one, I'm going to multiply out that first bit. So I'm going to x squared plus 7x minus 30. And that allows me to see that this is a trinomial, like I've used 100 times before, right? So just trinomial, use that AC method to do that factoring. So here I'm looking for terms that multiply to negative 30 and add to 7, right? And in this case, that's going to be a positive 10 and a negative 3. So that'll give me x minus 3 in the first set of parentheses and an x plus 10 in the second set. Remember, I can jump straight from this step to the next one only because that leading coefficient is a 1 for this trinomial. You could also, if you wanted to, go through that whole method, putting into 4 terms, doing factoring by grouping. If that feels more comfortable to you, definitely do that. And then lastly, we can use that zero product property. So I can have x minus 3 equals 0, or I can have x plus 10 equals 0, which will give me x equals 3, or x equals negative 10. Now, just like in the last problem, when we got a negative and a positive value, we had to sit there and think, does a negative value make sense here? Well, here that x, it's my width. It's a length, it's a measurement of something. So it can't be negative. I can't have negative 10 feet of fencing. So I have to have that 3 feet of fencing. So what I'm going to have is that Allie's fence has a width of 3 feet. Then I'm going to go back, I'm going to figure out the length. The length is 7 more than the width. So that'll give me that the length has to be 10 feet.